Hi everyone. This lesson is about sketching graphs of trigonometric functions. So here's a few examples for us. Now, part A, first of all, we notice that the base function here is a sine function. So y equals sine of x is our go-to function. So I'll start by plotting sine of x. So sine of x, that would be pi over 2. There's pi, negative 3 pi over 2, 2 pi. There's my base function for y equals the sine of x. Now what have I got here? I've got subtract pi over 2. So this represents a horizontal shift. If I make a note over here that our function could be y equals a by the sine of bx plus c plus d. So that's everything we can do. Now in this first example, it looks like a equals 1, so our amplitude will stay positive 1. It looks like d equals 0, so our equilibrium position will stay as the x-axis. It looks like b equals 1, so our period will still be 2 pi. But this is the bit here, c. Now remember, the horizontal shift is c divided by b. That's the horizontal shift. So in our case, this number, pi over 2, divided by 1, so it's still just pi over 2. Because it's subtract, it'll move to the right. So remember, pi over 2 is that far, so the 0 point will jump to there. The maximum will jump to the right. This will jump to the right, this will jump to the right, this will jump to the right. So this will be my translated graph. And of course it would continue backwards, like that, just like our base function would. So let's take a look on the graphing calculator whether we've got that right. So I've graphed the base function here. Now I'll just pop back and I'll graph sine of x take pi over 2. Being careful that my calculator is set to radians here. And there it is. The red graph represents our transformed graph that we just saw. Isn't that lovely? Let's try one more. I might try a cosine graph. Let's try this one. So our base function is cosine, and it's y equals cosine of x. So cosine, remember, starts at positive 1, then goes to 0, goes to negative 1, back to 0, back to positive 1. This is our basic cosine graph, y equals cosine of x. Now what have we got? Well, everything I said over here is still true if our base function is cosine. We still have a for amplitude, b for, now b, remember, is related to the period. b equals 2 pi over the period. D is the vertical shift, and c divided by b is the horizontal shift. So we still have amplitude 1, so still up and down by 1. We still have horizontal shift d of 0, so equilibrium line will still be the x-axis. b equals 1, so period will still be 2 pi. We do have a value for c, pi over 6, divide by that b value of 1, so pi over 6. Pi over 6 isn't very much, is it? And because it's plus, it'll be shifting to the left. So that's pi. Pi over 6 is really just about there. So that one will move back a little bit, that one will move back a little bit, that one will move back a little bit, that one will move back a little bit. My graph, my transformed graph, will be a bit like this, and it would continue. Let's see what the graphing calculator has to say about this. So I'll just pop back. Now I'll need to change my base function to read cosine, and I need to edit this one to be pi over 6. It'll have to be plus, and it'll have to be cosine. Let's draw those. Looks pretty much like we thought. The blue graph is the base function, And the red one, which is shifted just a little itty bit, pi over 6, to the left, that's the one I tried to draw in there in red. Drawing them by hand is always a bit rough, but you have to be able to do it. So practice makes perfect. Thanks for watching.